Welcome back to the very last video of the school year. This is Module 10, Lesson 6, Part 2, where we're continuing our study of interpreting histograms. When we left, we had done our Learn page here, where we talked about all the vocab words associated with the histograms and what you needed to know with them. And now we're back on to example number 2, where we're going to apply those terms into our lesson. The instruction says that a histogram shows the duration in minutes and seconds of solar eclipses over the past 10-year period. Use clusters, gaps, peaks, outliers, and symmetry to describe the shape of this histogram. So let's get on with this and see what we have to work with here. First off, step 1 says identify any symmetry, clusters, or outliers. Is there any symmetry going on here? And the answer is no, there isn't. It's a downhill slope, one-sided, so there is going to be no symmetrics taking place. That's going to check. The next question, are there any clusters? And the answer is yes. You've got this cluster going from 1 second up to 7 minutes and 30 seconds. That's going to check yes. The next question says, it says what I just said, there is a cluster from those sections. And then finally, are there any outliers? Now, you've got this one thing out here that's all the way up at 10 minutes, 1 second to 12 minutes, 30 seconds. I haven't mathematically proven it's an outlier. It is separate from all the others. So let's see what happens when I say yes on that. It is not an outlier. Even though it is separate from everybody else, it is not going to be 1.5 times the interquartile range plus that third quartile data value. So the correct answer for that is in fact going to be no. It looks separate, but it's not separate enough to constitute an outlier. The next question the textbook has for us is, are there any peaks? And the answer is yes. Right here between 1 minute and 2 minutes 30 seconds, there is going to be a peak. And the next question is, how many peaks are there? There's only one. The peak is the single tallest point. If you had 2 different bars going to the same height, then you would have 2 different peaks. But right now you only have one. The next question says, so it just states it once again the same thing. The only one peak goes from that height. All right, that's good. Let's move on to part 3. Are there any gaps taking place? Yes, there is, right here between 7 minutes 31 seconds and 10 minutes. So we're going to hit yes on that. And then from there, it says how many gaps are there? Just one gap. And like I said, 7 minutes 31 seconds and 10 minutes is going to be the gap. Now, we're going to describe the distribution. The data is not symmetric. The data does not contain any outliers, and the data cluster around 1 second to 7 minutes 30 seconds has a peak from 1 second to 2 minutes 30 seconds, and there is a gap between 7 minutes and 31 seconds and 10 minutes to 10 minutes right here. So right now we've established the fact that it is not symmetrical, and it does not contain any outliers there. Good. Let's keep moving from there. Yep, that's pretty much it. So what can you infer from the solar eclipses using this data? Well, looking at it, I can infer that most solar eclipses last between 1 second and 2 minutes 30 seconds. And every now and again you get these awesome little freaks of nature like 10 minutes 1 second all the way to 2 minutes 30 seconds. And if you believe the Bible, there was actually one day in the Bible where they said the sun was blocked out for an entire day. Just a little fact there. And now it's going to be your turn. Pause the video, work example number 2. The histogram shows the wait times in minutes for entering a concert. So you can see right here, you've got all these different wait times listed. I can see a cluster, I can see a peak, I can see a huge old gap, and I'm pretty darn confident that one's going to be an outlier right there. So let's answer the questions. First off, is it symmetric? The answer is it is not, largely because of that outlier. If that outlier had been adjusting this one to the same height as that and that to the same height as that, it would have been symmetric. But it is not going to be symmetric. Next, drag the time spans to the appropriate boxes. So first off, we need to take and find the peak. The peak takes place from 20 to 29. So at 20 to 29, I'm going to have a peak. The gaps are going to be from 50 to 89. So I've got a 50 to 89 is going to be a gap. Next, I've got clusters. It takes place from 0 to 49. That's going to be my cluster. And then the outliers, yeah, I'm pretty darn certain that one's going to be an outlier. 90 to 99, check. Everything checks. And that's all there is to doing it. Next, we're going to take a look at the box plots and learn how to interpret data that are on them. So, we'll get the question asked, how does a box plot reflect changes in data? Well, let's find out. There's 10 slides to go through here, so hopefully they will go quickly. First thing we're going to do is select some buttons. It says to, let's scroll down just a little bit. We can take a look at the median, which is going to be right there. The quartiles are showing right there. The interquartile range is going to be that section, and then the whiskers are going to be that section. So remember, your box itself is the interquartile range, and your whiskers go to the least and greatest values. So we have just created the box plot based off the data that they gave us. Next, we're going to take that box plot and use it to interpret some data, I suspect. From here, they want us to take and drag data points one at a time to see the effect. So, example, if I was to drag this one right here, way out, how's that going to affect everything else? No, not really that much. If I was to take and drag the median way over here, I'm thinking this thing isn't doing what it's supposed to be doing. All right, we're going to skip this and get on to the better part of the lesson. Although a box plot does not show individual data values, you can still describe the distribution of the data. Box plots are constructed using a median or middle data value and interquartile ranges. So use those measures to describe the center and the variation of the data. Because a box plot does not show individual data values, the mean or average cannot be found unless the data are perfectly symmetrical. In that case, the mean and the median, of course, are going to have the same value. So we're going to select some buttons down here to see what happens. First off, we got the symmetric button, and on the symmetric button you can see that the whiskers are the same size, the two halves of the main box are the same size, everything is going to be perfectly centered on the median right here. Not symmetric would be something like this, which has been skewed to the left because it's this would be skewed to the right because you had a data value which pulled the median over closer to the right. And then an outlier is right here, and when you have that outlier that totally separated itself from it, then all of a sudden you have a symmetric graph right here again, and then this outlier kept it from being skewed at all. For example 3, we have a box plot that shows the daily attendance at a fitness club. Describe the distribution of the data, including any symmetry, outliers, measures of center, measures of variation. What are the key parts of the box plot you will need to examine? Well, let's get into this one. First off, I know that that box plot was not symmetrical. We also have this outlier here, a day that's probably the day after New Year's Eve, when everybody started that New Year's resolution to go work out, and then they all got lazy again and quit going. But one day they had 110 people show up at that gym. So when you look at the values here, our median, that's going to be 70. That was your middle value. Your symmetry, there is going to be no symmetry going on here at all. I'm not sure what it's supposed to see when we click that symmetry button because there's no symmetry that occurs. Here he goes. The median segment does not divide it into two equal boxes, so it's not symmetric. Next, the outlier, that's going to be right here. 110 people is indicated by the asterisk. And finally, the interquartile range, that was from 65 to 80, which means that half of the time you have approximately you have between 65 and 80 people show up, and that was 15 or 15 out of the 30 days of that month that they tracked it. The left part of the box is going to be your shorter quartile, and that means that 25% of the data is going to be between, well, you've got 55 right here and 65 right there. So we got 55 and 65, because remember each quartile is 25%, And these data values are what? Well, they're looking pretty close together, I think. So we're going to say closer together than the data values and the other whisker. I'm sorry. So the other whisker goes from 80 to 90. It's also 10, so they're actually going to be the same distance. So that just doesn't make much sense to me. But let's go closer together and see what happens. It says, hold on. Oh, I see. They asked for the box, not for the whiskers. So the box goes from 65 to 70. So we're going to change those to be 65 and 70, and that is going to be closer together than the data in the other part of the whiskers are. So this group right here, that's going to be the most common group that occurs. 25% of the people occur in this 65 to 70 people a day window. And now it is time for our very last resource, our very last extra example problem for you to work on your own for this entire school year. Let's take a look at it. The number of games won by teams in the American Football Conference at a recent year is displayed in the box plot. Describe the distribution of the data, including any symmetry, yada, yada, yada. All right, first off, is it symmetric? It is definitely not symmetric because it got it skewed to the right over here. The data does not contain any outliers. There's nothing there with an asterisk going on there, so it's going to be does not contain any outliers. The median is going to be this value right here. So the middle value was 8 games won. Half of the teams therefore won fewer than 8 games, and half of the teams won more than 8 games that year. The interquartile range, that's going to be 11 minus 5, which is going to be 6. That means that the number of games that the middle 50% of the teams won is going to vary by 6 games. And then the whiskers, which one is going to be shortest? The right whisker is going to be shortest. That means that 25% of the data are going to be between, well, what do we have here? 11 and 13. So 11 and 13. Check our answers. We get a happy sound on our last problem, and we are done for the year. Finish that last homework assignment from your textbook, and I'll entertain any questions you have in class tomorrow.